Hatchett's Chief Executive Officer of the Coalition for Epidemic Preparedness Innovations, which supports the development of vaccines against epidemic diseases such as Ebola and Nipah, and technology platforms to allow the rapid development of vaccines against emerging threats such as COVID-19. CEPI helped establish and now co-leads the COVAX pillar of the Access to COVID-19 Tools Accelerator, ACT-A. Dr. Hatchett was previously the acting director of the U.S. Biomedical Advanced Research and Development Authority, BARDA, and served as director of medical preparedness policy on the Homeland and National Security Councils under Presidents Bush and Obama, respectively. He received his medical degree from Vanderbilt and completed clinical training in internal medicine and medical oncology at Cornell and Duke. And let me just add that it's not included in the official bio. I happen to know that he's exceptionally talented at herding cats. So with that, over to you, Richard.
Thanks, Stephen. You may have jinxed me because I have one cat at home that I'm not very successful at herding who may show up at an inopportune moment and present himself on screen. No, thank you for the introduction, and it's great to be back with you virtually and to see old friends. I'm going to give a quick tour of kind of our experience of the pandemic. Actually, probably spend most of the talk focusing prospectively on where we're going, at least, and I'm sure there will be ways, hopefully, that we can engage with the projects that you're undertaking and the kinds of analyses that you do so well. I have this deliberately archaic title that I chose. I don't know how many of you are familiar with Richard Henry Dana's book, 2 Years Before the Mast. I think it was published in like 1840. It's one of the great works of travel literature, one of the great works of American literature. And it's notable. He was a young student at Harvard, and he sailed out around the world on this expedition for 2 years, came back and wrote about it with great humanity and empathy for the peoples that he encountered along the way, as well as having great adventures, including rounding Cape Horn in the middle of winter through tremendous storms and travails. You know, we're coming up, we've just passed really, I guess, 2 years of the declared pandemic. So the title of the expedition seminar is what prompted the connection. Let me start just very briefly with a little bit of background about CEPI. I hope many of you are somewhat familiar with it. We were established in 2017. This chart showing the times from identification, isolation of a pathogen and the production of effective vaccine shows over the decades sort of progressive shortening of that time until you get down to Ebola, where you have a really extended period. And that extended period had a lot to do with the lack of a substantial commercial market. And so a vaccine that had been under development for at least a decade by the time of the Ebola outbreak in West Africa hadn't really advanced to the point of being ready for clinical deployment. And it was the realization once that vaccine was accelerated and deployed, and it came to be understood how effective it was and how it could essentially have prevented the vast majority of the West African epidemic if it had been ready in time. That stimulated global health leaders to focus on countermeasures development for emerging diseases in a more serious way and led to the establishment of CEPI. And as you'll see with COVID, I would say in certain respects, just in time. CEPI as an organization, the C is for coalition. That's actually a very important part of our identity. We bring together partners from across multiple sectors, illustrated here, with a single mission of accelerating the development of vaccines in coming years, other biologic countermeasures against emerging infectious diseases. The second part of our mission that is really critically important and is important to understand as we go through the rest of the talk is to enable equitable access to those vaccines for the populations that need them. By this point, we have become an organization with globally dispersed investments. We've got over 70 partnerships in place, over 200 different awardees and sub-awardees representing the geographies illustrated on the map. We have close to 30 investors, principally sovereign investors, countries, and of course the Gates Foundation and the Wellcome Trust is the most significant of a small cluster of philanthropies that are supporting us. I don't need to describe the impact of the COVID-19 pandemic. It started just before CEPI celebrated its 3rd anniversary, and the last 2 years of responding to the pandemic has really transformed CEPI as an organization. We ultimately have invested at this point, exclusive of our prior investments in MERS vaccines, and we had about $140 million allocated to MERS vaccines. We've now invested, I believe, around 20 different COVID and coronavirus vaccines. For the last year, we've been emphasizing the development of broadly protective vaccines, hopefully ultimately pan-beta coronavirus or pan-coronavirus vaccines, and those added to the original pool of 1st and 2nd generation COVID vaccines. We've got about 20 vaccines, and I think we lay fair claim to having the world's largest coronavirus portfolio at this point. We had to step into the breach because there were no other organizations to do it and expand our activities into manufacturing. We funded a significant amount of enabling science, set up a global set of centralized laboratories to support vaccine development, and have been pulled into issues of managing supply chains and matching upstream and downstream partners in the supply chain to overcome spot shortages. And of course, we have been focused on access in COVAX, and I'll talk a little bit about the COVAX story in just a minute. For us, the pandemic, we first became aware, like the rest of the world, that something was going on in Wuhan right at the end of December 2019. We elevated our alert posture in the first week of January. The week of January 15th, it became very clear that the number of cases were beginning to accelerate. And January 23rd, which happened to be during the World Economic Forum in Davos, which was interesting because it congregated in this one small town up in the mountains of Switzerland. You had important industrial leaders, important global health leaders, important political leaders as the virus was exploding. And there was lots and lots of crosstalk and conversation. On January 23rd, a couple of significant things happened. In fact, we were co-hosting a meeting that evening with Johnson & Johnson, which had the unfortunate title of Ending Epidemics or something to that effect. But that morning, we actually announced our first vaccine development contracts. We moved very, very rapidly. This is a photograph from a press conference that we held. I'm sitting next to Stefan Bancel, who's just to my right in the photo, the CEO of Moderna. They were one of the partners that we established our first contracts with. And Stefan and I, actually, our first communication about him needing funding to support the production of clinical trial material was on January 20th. And by January 22nd, we'd signed the contract and we were announcing it on the morning of January 23rd, just to show how fast things were moving at that point. Later that evening, before the unfortunate Ending Epidemics gala that we were holding, Seth Berkley and I sat down in a bar and began to think about the problem of access for vaccines and how we might enable access more effectively than we had been able to do during the 2009 pandemic, in the event that the virus in Wuhan ultimately spread globally, as we were quite concerned that it would. And from that conversation, the seed was planted that ultimately became COVAX. For most of the pandemic, in addition to supporting our R&D activities, we have been deeply involved in setting up COVAX as a mechanism, an end-to-end mechanism to support R&D, procurement, allocation, and delivery of vaccine globally. And that has really dominated our experience of the pandemic. It has also put us into the middle of conversations about global equity and global public goods as they relate to vaccines and other medical countermeasures. And I think even though COVAX didn't succeed in its stated objective, at least numerically, of delivering 2 billion doses globally by the end of 2021, I think it did accelerate that focus on equity, the conversation around equity. And I do think it had a positive impact in terms of speeding access to vaccine globally, even though inequities in that access did emerge. COVAX was conceptualized first, actually, as a multi-sectoral partnership between Gavi, CEPI, WHO, industry partners. But rapidly, the idea that formed around COVAX was expanded to include other countermeasures and something called the ACT Accelerator, the ACT standing for Access to COVID-19 Tools Accelerator, grew up out of that, and it has become a forum for coordination of activities around countermeasures, including therapeutics, diagnostics, oxygen, and other medical products. This is just a photo. Some of the organizations involved in setting up the ACT Accelerator are included at the bottom. The opening event, the announcement event in April 24th, 2020, included a number of heads of state, Dr. Tedros, Melinda Gates, and others. COVAX, as a global effort, has now involved the active participation of 188 countries, donors and participants who are receiving vaccine, including 86 countries that were eligible from the 92 countries under Gavi's advanced market commitment. These are for the poorest countries in the world. It actually represents the largest multilateral undertaking since the Paris Treaty on climate change. And it's had its ups and downs, but I think for something that did not exist 2 years ago, to grow this quickly, engage global leaders this quickly is really extraordinary. And it speaks to what galvanizing external threats, how they can, even though they do sometimes foster self-interested behavior and fear responses, they also foster collective effort and coordination, willing coordination of effort. And I think COVAX exemplifies what's best about multilateral effort in that respect. It also exemplifies many of the challenges. To date, 144 participants, I say participants because it includes countries and what we have to refer to delicately as economies like Taiwan and Hong Kong, have received doses through the COVAX mechanism. As of today, 1.39 billion doses have been distributed through COVAX, 1.22 billion to that list of 86 of the poorest countries in the world. And it accounts, I think, for about 80% of or more of the vaccine that the AMC participants have received. These are just some photos from vaccine arriving in different countries over time. So that is, in a super quick survey, that has been our experience over the last 2 years. And we have been close observers of the challenges of delivering and scaling vaccine, the challenges in regulating it, the challenges in securing cooperation or participation in a global effort, the ups and downs of vaccine uptakes, the challenges of vaccine hesitancy, and of course, the overall impact of the pandemic. The latest IHME estimate that was published a week or so ago of the global excess mortality of 18 million deaths, our World in Data currently estimating between a range of 14 to 24 million deaths. I think the Economist thinking probably 20 million excess deaths. All of those numbers in aggregate are in the range for the total excess mortality from World War I. And that's all accumulated just in the last 2 years. And it is testament to how difficult pandemic events, because they're distributed over time and vastly over space, how difficult they are to perceive and grasp correctly. I mean, I think the divisiveness and the tensions and the arguments about what is or isn't appropriate to do about vaccine mandates, mask mandates, all speak to the difficulty that individuals who are enmeshed in the event and in a single place and in a single moment in time, their difficulty in sort of appreciating the scale and scope of an event, which, as I said, has probably now taken as many lives as World War I took, which was an epochal event in the 20th century. And it speaks to the challenges that we will face in the future, which is what I really want to spend most of the discussion talking about. As our role in the acute response in terms of supporting the first generation vaccines has somewhat diminished and declined, we have had the leisure, also the necessity, because our funding ran out at the end of 2021 from the first 5 years, to think about what the world needs to do in the future to address these threats, to be more prepared for these threats, and what CEPI, as an organization that is part of the international pandemic and preparedness and response architecture, what we need to be doing. And we've laid out what we call our CEPI 2.0 agenda. We've roughly bucketed the activities that we're proposing under these pillars of prepare, transform, and connect. I'll talk a little bit more a few slides later about the different elements under each of the pillars, but we think there's a tremendous amount that we can do to be better prepared for future threats, even threats that we don't know about today, that we can transform the countermeasure development process if we focus on doing so, and that we can do all of that in a context where our ultimate goal is to create global preparedness and to eliminate or to focus on the causes of the inequities that we have seen emerge first in 2009 and more recently, particularly last year, in terms of access to countermeasures. This is all kind of encapsulated under what we call the 100-day goal, 100-day mission to deliver vaccines for use within 100 days of a trigger to start vaccine development. And that's obviously a very ambitious goal, but one we think is absolutely necessary. And I'll talk about that in just a minute. Many of you may have seen this photograph. You may not realize the significance of the photograph. It's from actually the fastest vaccine development effort before COVID-19. This is actually Maurice Hilleman's daughter, Kristen, in the center, receiving a dose of the mumps vaccine that her father had developed based on a viral specimen that he secured from his daughter, Gerald Lynn, who is pictured on the left, comforting her younger sister who is receiving the vaccine in the early clinical trials of that vaccine. Gerald Lynn's mumps virus was isolated in late 1963. This photo from the clinical trials is from 1966. And the vaccine was ultimately licensed in 1968 after just a little more than 4 years of development from virus to vaccine. To put that in context, if that timeline had obtained for COVID, we would just be entering the clinical trials period now. Where we are now, we've actually manufactured almost 12 billion doses of vaccine, and almost 11 billion have already been administered. So it really speaks to how far we've come. There's Maurice Hilleman, great hero of vaccinology that I'm sure many of you are familiar with. In reducing the vaccine development timelines down to 326 days, actually, from release of viral sequences to the emergency use authorization in the UK of the Pfizer vaccine, you can see that what had been sort of the industry averages for the various stages of vaccine development, the dots on the top represent months for each of these typical stages for vaccine development. The reduction of the timelines down to the months that were achieved during 2020. And it is a pretty remarkable reduction. We've engaged McKinsey to go back and look at the actual experience of different vaccine developers in 2020 and where they were able to innovate to cut these timelines. And they identified essentially 5 areas, 5 big buckets where innovations were occurring, which are listed here. I won't go through these in detail, but they were able to identify specific innovations in each area. Different manufacturers discovered different ways of accelerating. There was no cookie cutter approach. And so our goal in going back to look at the 2020 experience in detail for the different manufacturers and different regulators was to think about what could we, if we optimize from all of the lessons learned across the different manufacturers, what might we be able to achieve? I think I've already made this point. The 326 days that were observed in 2020, yes, new land speed record, yes, remarkable, astounding result. If you look at the outcomes, now with somewhere in the range of 18 to 20 million deaths, 2.5 years into the pandemic, and in the year 2021, the year that vaccines became available, essentially twice as many deaths recorded that year as in the first year of the pandemic. It's obvious that we have to do better than 326 days, particularly given that I think we all recognize that emerging diseases, the tempo of new emergences and the intensity and the scale of outbreaks that are occurring is increasing over time. The COVID pandemic, already the second pandemic of the 21st century, and by my count, the seventh global infectious disease crisis of the 21st century, if you count SARS, avian influenza, swine flu, MERS, Ebola, Zika, and COVID. We simply have to make systematic investments in preparedness. Now, if you will humor me, but I'd like to make a point about how we might speed things up.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
It's humorous, but it makes a serious point, I think, very effectively, which is in the later example, you had a highly specialized team who had specialized, very concrete tasks and were prepared, and you could see them leaning in, waiting for the Formula One racer to come in. They were instantly able to execute their work and obviously drastically, by doing that, have drastically reduced the time for getting the car out of the pit stop. And of course, the car has also been designed in advance to allow that kind of rapid turnover rather than what seems in 1950, I'm sure getting a car out of a pit stop in a minute seemed astounding, but actually now looks lackadaisical. That's essentially, in a nutshell, that is what we would like to do with vaccines in the future. Have the vaccine testing platforms developed, ready, and be able, as soon as a new pathogen is identified, to map it to a prototype vaccine where we've solved some of the problems of vaccinology so that we can move immediately into clinical development, then have the clinical development and manufacturing platforms teed up like the support crew in the second video so that they can move immediately to perform necessary testing and get the vaccine out of the pit stop as quickly as possible. It doesn't mean that we'll have full phase 3 data. It doesn't mean that we'll have full safety information, but depending on how much we invest in on the preparedness side, we can do that with greater confidence. And if we have systems in place and have made appropriate investments to gather data in real time as vaccines are rolling out and being deployed, either for containment efforts or to protect the most vulnerable, we think we can do much better, and that would result in very significant mitigation at worst of potential future pandemic threats. And ideally, if coupled with earlier surveillance, detection, and warning, and intelligent use of targeted but intensive non-pharmaceutical interventions, I think it gives us a prospect of preventing incipient pandemics from becoming pandemic, and that needs to be the goal. I talked about the McKinsey work that we did where we went back and looked intensively at the different stages. What we determined from doing that is that there is a possibility using the current paradigm potentially to obtain still some incremental improvements, perhaps reducing the development time by about a third but that still doesn't get us down to 100 days. And what we really need to do is define what we need to achieve and then figure out how to do that. So we have talked about needing a paradigm shift, essentially, if we are going to get down to 100 days. That paradigm shift will essentially require the kind of front loading in preparedness investments. And we have embraced the NIH proposal around prototype vaccines, basically solving the problems of vaccine development for as many of the viral families that are known to cause human disease as we can. And that's depending on what day it is, and the state of viral taxonomy is probably somewhere between 25 and 27 or 28 viral families. We already have vaccines against diseases from 15 of those families, but they're not vaccines on rapid response platforms that could be rolled out as quickly as we will need them to roll out. So there's a translation project where we know we can develop vaccines. We just need to figure out how to do it on the rapid response platforms. And we need to look at the phylogenetic space, and some families may need multiple vaccine candidates to cover the phylogenetic space appropriately. But whether it's 25 vaccines, 50 vaccines, or 100 vaccines that we need to have in our vaccine libraries, it is a large but finite number. And we now have both a conceptual model for how to use those vaccine libraries to enhance preparedness, and we have the tools in the rapid response platforms that would enable us to achieve the 100-day goal. We also need to make investments during the 100 days in having the clinical trial platforms, clinical trial groups, subjects ideally pre-enrolled, protocols pre-developed, so that they can move immediately as soon as clinical trial material is developed. And we have to make investments in the space beyond the 100 days to make sure that we can scale the manufacturing up to whatever scale is necessary, and that we have data collection systems that allow us to assess the safety and field efficacy of the vaccines as they are rolled out. In a report that we have yet to publish, it will be out pretty soon. We're in the final stages of development. We talk about the different kinds of innovation in science and development excellence and in policy that will be required to move the world towards having that 100-day capability. The 100-day goal would be the default target, so that as soon as a new and apparently communicable disease breaks out, we would pull the trigger and be shooting towards 100 days. We would also be paying attention to what's happening and what's unfolding epidemiologically over time, so that we can pivot to longer development timelines or doing more of the work on safety and efficacy before releasing vaccines if the epidemiologic context is appropriate. So you start by shooting for 100 days in case you need it, and if containment is achieved with traditional public health interventions, that may change the urgency of completing the vaccine. It may change what you're willing to do within an experimental context versus an emergency use context. But that's kind of built into that flexibility. The ability to take off ramps to stop, of course, is built into the preparedness paradigm. The last point I would want to make just about the program is that in our effort to accelerate vaccine development, and I think the concerns about vaccine hesitancy are here, we cannot take shortcuts on safety or on performing continuously updated risk-benefit assessments as we go forward. As I said, the goal with the different viral families and the focus on the vaccine libraries is to collect a substantial amount of safety information about platforms and about related viruses, and to collect information about the immunogenicity of the vaccines and the nature of the immune response that is required. To do all of that in advance, so that the limited safety data set you're able to accumulate in 100 days reassures you even as you undertake a really intensive pharmacovigilance after you begin to release vaccine. And you may release vaccine, as I said, in very targeted ways, either for very specified geographies where transmission is occurring, or for the highest risk groups that seem to be suffering the most from the new agent. We also have to build into our system approaches that enable equitable access to vaccines from much earlier in a response than was achieved in 2021. I'm very pleased to say that the 100-day mission, as we articulated it, seems to have captured the imagination of political leaders. The UK government picked up the 100-day mission, formally made it part of their G7 presidency in 2021. It was endorsed by the G7 in the leader's statement emerging from the Corbis Bay Summit in Cornwall in June of 2021. And it carried over into the G20 process and was also endorsed by the G20 Rome Leaders Declaration at the end of 2020, and now is being brought into the German G7 and Indonesian G20 processes, and also figures in and is cited in America's Pandemic Preparedness Plan that was released late last year. So there does seem to be an emerging consensus that that is a appropriate global goal. It's not a goal that CEPI can achieve by itself. We need the countries that fund R&D to buy in because it is big. It is a big but technologically achievable goal. Some of my colleagues like to refer to it as our moonshot. I don't like moonshot because that's derivative of somebody else's project, but I think there's an appropriate analogy there in that when Kennedy announced the moonshot goal, it was because it was already technologically within reach. It was an engineering problem, a focus problem, a resources problem. And I think our ability to dramatically reduce pandemic risk falls into the same category. I mentioned that we have a 5-year program, CEPI 2.0, that we've created these buckets. The elements under each of the buckets, the prepare element focuses on being prepared for threats we know about. COVID-19, coronaviruses, Ebola, Lassa, Nipah, other diseases where we need vaccines for specific priority pathogens and capabilities for those pathogens. The transform pillar is largely what I've been talking about, which is building the vaccine libraries, developing the capabilities, creating a global effort to focus on achieving that 100-day capability. The connect piece is where we focus on equity, focus on creating global collaborative networks to advance this agenda as quickly as possible. If the world were to undertake a coordinated effort, I think we could actually populate our vaccine libraries in as little as 5 to 7 years. And we could also create the systems through which we could accelerate vaccine development in the 100 days within that period. And that would dramatically take down the risk of future epidemics and pandemics, potentially even eliminating that risk altogether if, as I said, we can couple it with similar enhancements of surveillance capability and more intelligent use of non-pharmaceutical interventions. I'll just finish with a couple of snapshots. We just convened as part of our resource mobilization effort for the CEPI 2.0 agenda, the Global Pandemic Preparedness Summit. This was one of our hosts and MCs. She was a young actor in the UK. She opened the Global Pandemic Preparedness Summit with this remarkable sort of slam poetry history of vaccine development and humanity's encounter with pandemic diseases over the eons. She's standing in front of a picture of Jenner in this particular photo. The recording, if you're interested, is actually available. You can watch it. That's if you had to watch one thing from the Global Pandemic Preparedness Summit, I would encourage you to watch her performance. The website is here on the slide. These are just some of the speakers. It was really remarkable. Dr. Tedros, the Director General of WHO, came, participated, stayed in the room for the entire day and a half of the summit. Antonio Guterres sent a video message. Sarah Gilbert spoke. Soumya Swaminathan, Chief Scientist at WHO, a number of ministers of health. Really remarkable turnout. The colors we had selected months in advance, and they just happened to be appropriate given the backdrop of the crisis in Ukraine. And actually juxtaposing the pandemic crisis and the geopolitical crisis of Ukraine prompted some very interesting discussions and reflections on the different ways in which politicians and governments respond to different kinds of personified and non-personified threats. At the end of the day, we were able on the day to raise about $1.5 billion towards the CEPI 2.0 goal. We probably have somewhere on the order of another 500 million to $1 billion that is kind of in process, working its way through various budget processes. So a really good head start for a 5-year program. Great participation, both in person. We had over 300 people in person and virtually. That's kind of where we are. Stephen, I hope I've kept to time more or less, and certainly would be happy to take any questions.
Well, thank you so much. And I'm really glad there are people with ambitions like yours out there working on this. It's really wonderful to see this program. I'm going to take advantage of my position as chair here to ask the first question, but we have quite a bit of time for questions. So I was interested, as you alluded and towards the end, that there's so many crises facing us right now, conflicts and global climate change. I'm really concerned that the issue of pandemic preparedness is going to fade away really fast when COVID ceases being in the news every day. And I'm wondering if you see much overlap between, especially the later parts of this 100-day mission and just global health security in general. Are there things like manufacturing capability and ensuring supply chains are protected that both things can make use of?
I do. I mean, I share your concern. Peter Sands has elegantly expressed it as cycles of panic and neglect about infectious disease threats. One of the things that I'm concerned about, and I experienced this as I was trying to undertake the resource mobilization efforts for CEPI 2.0, is that governments tend to view pandemic preparedness either, if they're thinking about it domestically, as a health problem, as something to be sorted out from health budgets, which tend to be constrained, or, and this is before COVID, or when they're thinking internationally, they tend to think, oh, this is something that we'll throw a few development dollars at. And for what is fundamentally, in my mind, a security problem viewed broadly, that's inadequate. I mean, the example would be if, in responding to Ukraine, all the countries of Western Europe tried to manage their support by, drawing on their development funds and figuring out, what they were going to take away from TB so they could send military assistance to the Ukraine. And they don't do that because they recognize it's a security problem and it's a fundamental responsibility of government to find the resources to address the security problem as the security problem stands, not according to how the governments routinely in peacetime allocate their dollars through different channels. And I do think governments need to reconceptualize their understanding of the threat that infectious diseases present, and not across the entire spectrum of infectious, but specifically epidemic and pandemic diseases. And then they need to configure the governmental funding mechanisms in a way that is adapted to the problem rather than trying to adapt the problem to their budget processes. And governments have done this before. The US has done this with defense funding. It's done it with intelligence funding. Once it wraps its head around what the actual nature of the problem is, and it is correctly categorizing and correctly perceiving the problem, it can then design budgetary and governance solutions that are appropriate to the problem. But no government, in my mind, has done that to date. And so there is a fundamental narrative that we don't have right yet. And I think that will lead to the skipping from crisis to crisis kind of mentality that you're concerned about. I do think there are ways to link the R&D agenda that we've just described with the aspirations of particularly the underserved regions to build up their vaccine manufacturing capability. And the new technologies may enable them to leapfrog over the old, hard, temperamental, traditional approaches to biological manufacturing. And because we're taking a viral family approach, a mumps vaccine or a measles vaccine is just as legitimate an exemplar of a paramyxovirus as Nipah or Hendra. So there may be ways to use populating the viral families on the rapid response technologies to help provide useful vaccines to new capabilities that get built up. There's a lot more to it than that. And I was just on the phone earlier today with Beth Cameron and her colleagues talking about all the different ways in which that could go wrong or go south. But I think there is a way to do this intelligently and holistically that advances our preparedness without slipping back into old bad patterns of thought.
Thanks, Richard. Great talk, and I love that analogy with the Formula One car. I think that's really spot on. And I have every confidence that you guys will pull this off. I think this is something which, as you say, the world knows how to do. It just needs to focus and do it. I think you started answering my question a little bit, which is, as of today, only 15% of Africa is vaccinated with a vaccine that we've had now for almost a year and a half. And I think it's not just about manufacturing capability in these countries. It's also perhaps about, in the same careful way that you're thinking about having done the preparation on the platform and everything else for the vaccine when it arrives, or when you know what the pathogen you're going after is. In that same way, we also need to put down sort of the road or the rail network, so to speak, the supply networks for the vaccine into all these other countries, and figure out exactly what we're going to do when it happens. We can't do that in the time of the crisis. That's almost complementary to CEPI. I think that's not necessarily CEPI's skill set. Have you had conversations with Gavi about what this might look like? Because the COVAX mechanism, while well-intended, obviously didn't quite go off the way that it should have. But how are we going to get the development done in 100 days, but also get everyone vaccinated in 200 days?
We've actually just begun thinking about that. I mean, I mentioned the conversations with Beth and her team this morning, and we were talking about what you just described as the second 100 days problem. And there's a number of components to it. I mean, on the manufacturing side, you're right. CEPI isn't going to be building manufacturing facilities. What we're seeing right now is a bit of a disordered scramble. Everybody wants a manufacturing facility. Not everybody's going to be able to succeed or to sustain, even if they, manage to get one up and running. And the efforts of the African Union in particular to sort of bring some coordination and to focus and concentrate resources on a few locations, I think is very helpful, although that seems to be falling apart a little bit because every country seems to want their own facility. Mm-hmm. I think that's going to be really, really challenging. We think that the emergence of these regional mutual security arrangements through the pandemic is actually a very positive trend and needs to be supported. I mean, there are natural affinities within regions. Regions over time could build up some degree of self-sufficiency in terms of the more extended supply chain. That's one problem. The second problem, and I think you were also alluding to this, is the countries have to have the capability, wherever the vaccine is coming from, assuming there's a supply, they have to have a capability to deliver it. And that has been one of the bottlenecks that we've been encountering more laterally, and is probably the main problem for 2022, is that those bottlenecks of delivery capability, at some point, the demand among the populations will dwindle away naturally. And if delivering vaccine has been held up because of a bottleneck in delivery capability or capacity, that's a real problem. And it leaves pools of vulnerability if the virus continues, as it will, to evolve. John Bell, who you probably know, others, he's the Regis Professor of Medicine at Oxford, has talked about his aspiration that the COVID vaccine effort be leveraged to create adult vaccination programs in many countries that really haven't had adult vaccination programs, and establishing adult vaccination programs more globally. And there's a whole slew of vaccines that are really for targeting high-risk adults, would hopefully create a sustainable capacity that could serve in a crisis, or at least as a foundation in a crisis.
Thank you.
First of all, absolutely fascinating talk. Thank you very, very much for joining us. I know you're very busy. And Stephen, big thanks to you for having Richard come and join us. So I have two questions. First is a question that sort of begins from where you left the answer. But Raman and I was going to ask a similar question. But the question relates to the modeling part, right? I mean, the way we knew you, Richard, was through the efforts you led during the H1N1 and before that H5N1 scare and the modeling work. Do you see a role for modeling? And somewhat more broadly, this particular group, this expeditions program that we have, thanks to NSF, has really assembled outstanding modelers around. And we would like to help you in any way we could as a part of this. Irene, thanks for putting your camera on. It's very nice to see you as well. We know old friends. But if you could tell us if there's a role you think for modelers like us and how we could go ahead and help. I mean, we would really like to do this because I think it's an amazing cause that you have started.
As you know, it doesn't take very much to get me excited about the opportunities for modeling, and I absolutely think there is a role for modeling of different kinds and at different points in the problem. First, I have to say, hi, Irene, so good to see you. It's been forever. I mean, one area that has occurred to me through the course of COVID first was that when COVID first emerged, of course, my mind went back to TLC and targeted layered containment and thinking we had the solution in a box. And I think COVID illustrates, I mean, we knew that different pathogens with different kinds of shedding profiles and different generation times would require different sets of interventions. I mean, the work that Mark and others did, looking at SARS and looking at what was required to contain SARS, which was pretty straightforward, just isolation, quarantine, reducing time of, from diagnosis to isolation because shedding increased sort of linearly through the clinical illness. That's different for flu and different for COVID because they're different diseases. And the sets of interventions that would have been least socially costly while providing optimal transmission reduction for COVID are probably slightly different than the ones that would be necessary for flu. And I think there's an unbelievable amount of data, as Stephen and I were talking about right at the beginning, an unbelievable amount of data that has now been collected about different combinations of interventions. And I think there is a very important research program that I would have hoped we might have stimulated back in 2005, 2006 that sort of never got off the ground, looking at optimization of various different interventions, non-pharmaceutical interventions across different disease types or different spectra of biology, essentially. I think it's important that we really fully understand these tools because the next virus that comes along, that's still going to be the only thing that we have unless we develop broadly effective antivirals. And that's been scientifically challenging to date. I'm not sure that we're going to crack that nut immediately. So coupling earlier detection and warning with rapid, geographically targeted, but intensive implementation of interventions that can be sustained for as long as it takes us to deliver definitive countermeasures, whether antivirals or vaccines, those three things coming together that create the prospect of containment and prevention. And so there's a very important piece there to extract as much information as we can from the global experience with non-pharmaceutical interventions as possible, and then figuring out how to use them. That's just one modeling problem. Another modeling problem that occurs to me, for those who are interested in phylogenetics, is the 100-day mission. If it's dependent on the vaccine libraries, what do we need in the vaccine library? I mean, we've got a huge phylogenetic space that we need to cover as well as we can so that the odds are that we're going to have a reasonably related virus that we've already solved for when the next unknown virus pops out. And does that mean that we need, in the paramyxoviruses, for example, I mentioned mumps and measles, they're in sort of one corner of the phylogenetic space. Para-influenza viruses are in another. Nipah and Hendra are down in a third area. How many paramyxovirus exemplar vaccines do we need? That's a data problem. I think there's a modeling aspect to that. The final area that I think would be quite interesting, again, may not be the space that you guys are operating in, but maybe some of you are, is supply chain modeling and understanding how can we optimize manufacturing processes and how can we really intensively look at manufacturing processes, take them apart and figure out what we can do to shave those times for scaling to the greatest extent possible. Part of that's a biology problem, part of that's, a bioengineering problem, but I think there's also a modeling component to that. I should just say, just on that question, Madhav, I would love to connect you. We've got a small modeling group that we're building out within CEPI, and I'm trying to build on the Ebola effort when we had the network that we sort of established on the fly. I'd like to kind of reconstruct that in collaboration with Dylan and Mark at CDC and Chickway at WHO, but I'd like to make sure that CEPI's connected into that, and I'd be happy to connect them with you or Stephen if that would be of interest.
Yeah, that would be absolutely a great idea. We are here to really help. I mean, you have started a very important and noble idea here, and we want to, and our project actually asks that we do it. So anyway, we can support you. We'll be very happy to do that. So yeah, please, thanks so much.
So I was curious on that modeling front, if you guys have thought at all about the carrying capacity for the multi-strain vaccine deployment of the body and its ability to sort of manufacture multiple antibodies at once. And then if you've thought at all about deploying multiple versions of, say, an mRNA vaccine for a single target in the society at once to prevent a single signal from the virus, mutating away to achieve fitness away from one signal and having to deal with multiple?
The short answer is that we are thinking about it. I mean, actually, who's thinking about it are our partners. And we put together a program and now have funded maybe half a dozen, or probably several more coming, broadly protective, either variant-proof COVID vaccines or ideally pan-coronavirus or pan-beta coronavirus or pan-cervicovirus. We'd like it to be as pan as it can be. We don't know what is biologically feasible, but a lot of the ideas that have been brought in response to our call for proposals for that have entailed, I think, approaches that touch on the problem that you're touching on, which is basically multivalent presentations of antigens to the immune system with the goal essentially of trying to replicate the observation that Lin Fo Wang and his group in Singapore observed from survivors of SARS-1 who were subsequently vaccinated with COVID vaccines and demonstrated sort of a broadly protective immune response, and how to optimize that. I mean, I'd be delighted to put you in touch with maybe if Stephen could collect the various people that I need to connect. I'd be happy to connect you with our internal group that is thinking about that problem.
Yeah, great. Thank you.
Hi, Richard. Good to see you again. So I'm just going to kind of follow on to what Andrew was asking about. And that has to do with viral evolution and the importance of continuing to understand how viruses mutate and what the right response to that is in a pandemic situation. And that leads me more to thinking about the NIH mission about basic research. I mean, mRNA vaccines did not come out of nowhere. They were solidly based on decades of research that seemed very untargeted and uninteresting to many at the time, but they really shone in this particular case. So I guess my question is, do you see that governments and institutions are really willing to invest in the kind of basic research that can ultimately help us here?
I think it's going to remain to be seen, Irene. I mean, in the UK, the government is struggling. I mean, they've cut development budgets. They haven't cut research budgets per se yet, but the Chancellor of the Exchequer, just yesterday presented a tax-cutting move to try to deal with the inflationary pressures that are emerging from the pandemic and from the conflict in Ukraine. There are going to be intense pressures probably on most government budgets in coming years. And at the same time, I would think that the saliency of the threat and the awareness of the impact, this is no longer hypothetical, right? I mean, people were scandalized when Peter Sands was claiming that a pandemic might cost the global economy $6 trillion. They thought that was scaremongering, trying to secure resources. Well, here we are, and we're $14 trillion in at this point. So all of a sudden, these threats have a solidity that maybe they didn't have when they were just hypothetical. So I would hope that governments, among their many priorities, this wouldn't fall off the radar screen. But R&D it's also interesting in going out and seeking funding for CEPI's program. I'm doing that at the same time that Gavi and the Global Fund are seeking funds to buy vaccine doses or to buy therapeutics doses or diagnostic kits. And the tangibility of the return on investment for those kinds of investments relative to the return on investment for R&D, which is always partially speculative, it is interesting where we kind of fall out in the priority rankings. So this stacking of crises puts intense pressure on governments. I'm kind of reminded of Kyle Harper's book, The Fate of Rome, a few years ago, which talked about how the accumulation of both some moderate climate instability and recurrent pandemic disease in the late Roman Empire kind of eroded the sources of resilience, which had protected Rome from internal political struggle and external threats. For hundreds of years, they had been able to manage that very successfully and robustly. But then when you added on top of that some climate instability, periodic crop failure and pandemic disease, the empire just kind of fell apart. And I'm not to be a doomsayer, but I'm concerned that we're seeing similar dynamics on the limited capacity of our governance structures. Not to get existential all of a sudden.
Yeah, thanks so much for your talk. I really found it really fascinating. I wanted to ask a little bit about the supply chain issues. So if you're thinking ideal timelines would be like 100 and 200 days, then a lot of the manufacturing materials would have to be, I guess, stockpiled in many places.
No, that's a great question that I confess I hadn't even gotten to thinking about. Because if you are trying to scale rapidly, I mean, we've scaled remarkably. I mean, and there have been periodic pressures on different aspects of the supply chain along the way, but nothing that has been irresolvable or a crisis. But that's with sort of a 2-year timeline for upstream suppliers to scale up their production capacity, and they've done that at risk because it's not clear how long demand for vaccine is going to be sustained. But trying to do that in 100 days or 200 days is a dialing up the complexity of that problem. I would be also happy to connect you with our head of supply chain management. We've set up something called the Kovacs Marketplace about a year ago because of some of these spot shortages, and have been helping matchmake between upstream suppliers with excess capacity or excess inventory and downstream manufacturers that are finding shortages. And I thought that was going to be of limited utility, frankly, when we set it up. But I understand that something like more than 50 transactions have now been executed through that mechanism, which is astonishing to me that there was that much need. So I think if you do supply chain modeling, I think our team would be delighted to walk through some of what we're seeing.
I haven't done any. I'd love to. I think that seems like a really timely thing to learn.
Richard, just one comment following up what Anil said. It appears to me that the supply chain has this interesting form. There's a part that is to do with labor and material that comes into the production facility, and then part that Ramanan asked, which is the delivery side, which is also supply chain. And eventually, for the entire system to work, it has to do well. The marketplace idea you said is good, but one thing I find in these things is all the rules sort of get effectively knocked off once crisis hits, right? People have all sorts of nice agreements, but it appears that exactly when people should maintain these agreements, they often fall apart for various reasons that have to do with political realities and strategic behavior.
I mean, I think that's true. One of the things that we were hoping to achieve when we set up COVAX, and we knew we were racing against time, was the circumstances that obtained at the beginning of the pandemic with a variety of vaccine development efforts ongoing simultaneously, but not clear at all which ones were going to be successful or how easy it was going to be to develop effective vaccines against COVID. We were counting on the Rawlsian veil of ignorance being down and nobody knowing which vaccines were going to succeed, and seeing the benefits of buying a ticket in a big pool of vaccines. That's why we had so many vaccines in the portfolio, so that we felt like we could have a high probability of some of them succeeding, even if we didn't know which ones or which ones were going to come first. The flaw in the system, there were two flaws. One was there wasn't a financing mechanism that would have allowed us to put in advanced purchase orders at the beginning of the pandemic. And by the time we had gone out and raised money gone around with the tin cup and raised enough money to actually procure vaccine, the veil of ignorance had become moth-eaten at best, maybe even just shredded entirely. And the countries that had resources were sort of charging through it to the winners and buying up vaccine supply. The reason I mention that is that the conditions before the next pandemic are not going to be the same. We now have the validated technologies, and countries will have a lot more line of sight on who the likely fastest providers are going to be. And I suspect that they will do something that's somewhat analogous to what they did before the 2009 pandemic, which is that the rich countries that were concerned about pandemic influenza preparedness had gone and put contingent purchase contracts in place with all the vaccine manufacturers. And as soon as the pandemic started, they executed the contracts and bought up the global supply of vaccine. So we can be sure that that is going to, those kinds of arrangements, the companies aren't going to be able to resist that business model. And so we need to think about how do we, anticipating that, how do we offset that? Part of offsetting that is having globally distributed, more equitably distributed manufacturing capacity so that regions have some ability to provide for their own needs, even if they're not perfectly self-sufficient, that some regions aren't just being left out entirely while other regions are an embarrassment of riches, as it were.
Well, thank you so much. I'm sorry to have held you here, but you're fascinating our audience. And it's really good to see you again, and keep up the good work.
Thank you. No, it's a pleasure to see everybody. Thank you all for giving me time. I'm delighted to keep the discussion going. Take care, everybody.
Bye-bye.
Thank you very much.
Thank you.